Headroom starts from a very practical pain. Agents waste tokens not because they think deeply, but because they read too much junk. A single tool call can return long logs, stacked traces, JSON, large files, or RAG chunks. All of it enters context. Tokens burn before the model does the real job. Headroom puts a compression layer between tool output and the LLM. It processes data before the model sees it. The goal is preserve meaning and remove noise. The README numbers are direct. Code search across 100 results goes from 17,765 tokens to 1,408. That is a 92% reduction. The SRE incident case is heavier. 65,694 log tokens become 5,118, also a 92% reduction. GitHub issue triage drops 73%. Codebase exploration drops 47%. The noisier the workload, the more room compression has to work. The first integration mode is library. Python calls compress messages. TypeScript has the same path. Use it when you control the application code. The second mode is proxy. Run Headroom proxy port 8787. Point existing API calls at it with almost no business logic change. The third mode is agent wrap. Headroom wraps Claude Code, Codex, Cursor, Aider, and Copilot. Users keep their familiar agent command. The fourth mode is MCP server. The core tools are Headroom compress, Headroom retrieve, and Headroom stats. Any MCP-speaking agent framework can use them. The engine is not a prompt hack. The README names Content Router, Smart Crusher, Code Compressor, and Compress Base. Different content types get different handling. Compress v2 base is the text compression model behind it. It is not just chopping off the top and bottom. It tries to keep important meaning in a smaller form. CCR makes the story safer. Originals are cached locally. When the model needs detail, it can retrieve the compressed source again. So Headroom does not force data loss. It changes the default from read everything to read the compact version. Detail still has a path back. The quality benchmark is the part worth checking. GSM 8K stays at 0.87. The delta is 0. Truthful QA even moves from 0.53 to 0.56. That is not magic proof, but it says compression does not have to degrade answers. BFCL tool benchmark hits 97% exact match at 32% compression. For structured tasks, that signal matters. Headroom also addresses output tokens. Output tokens often cost more than input. The output shaper drops ceremony, repeated code, and unnecessary response bulk. That fits coding agents well. Many answers do not need to be long. They need to be correct, concise, and actionable. Headroom Learn adds a failure learning loop. It reads failed sessions. Then it proposes or writes corrections into Claude, MD, agents, MD, or Gemini, MD. That turns context into an improvement loop. It saves tokens today. It can also reduce repeated mistakes tomorrow. Local first is another important axis. The README emphasizes local compression, reversibility, and local cache. For sensitive logs, that matters. This is still not a cure-all. If output is already compact, savings are smaller. If the source needs byte-perfect detail, retrieval must happen at the right time. The best use case is agents reading too much. Large repos, long logs, issue triage, many RAG chunks, or noisy terminal output. Bottom line, Headroom does not replace the model. It changes the context pipeline. Cleaner context makes agents cheaper, lighter, and still high quality.